doing. Today, inshallah, I will take you into a journey to see how mathematics is used with different courses that students are studying in school and in university, how these are used in different measures, or by different measures in different jobs and different fields. So I would like to review first with you the objectives of the session of today. So the objectives is to appreciate how mathematics courses are needed in many measures. Also recognize that graduates of certain degrees might work in many different fields. Knowing some of the examples of uses of math in different jobs, and also some of the awareness of some of the most practical advices regarding mathematics in life. So I want just to make sure I have access to the chat so I can see your questions and answers. Oh yeah, I can open the chat. Okay, just put it here. Very good. Because I'm going to be asking a lot of questions and I want to see your answers here. Okay, so look at the first one, appreciating how each math course is needed in many measures. Math courses needed in measures, different degrees. Like in engineering degrees, is math needed in engineering? You probably said, of course. How about in arts? How about in medicine? Do you think you need math? In science, and so on. So this is obvious actually when we look at the way I organize this here is different courses. So this is arithmetic courses, algebra courses, trigonometry, geometry, calculus, statistics, and so on. So these are different courses that you probably have seen, or maybe you will see in the university. So I mean, who is using these? Like, for example, if you look on arithmetic, which degree needs arithmetic? Which major needs arithmetic? That's the first objective. It's actually discovered that arithmetic is needed in engineering degree, in finance degree, arts also, not just math, and even in nursing. Okay, how about algebra? Who needs algebra? Why do we have to study algebra? So we will see that algebra is studied in degrees that are mathematical, math degree or physics degree or even science degree. And you will see how examples that people with science actually degree are benefiting from algebra. How about trigonometry? Who studies trigonometry and why? In engineering degrees, again, even art degrees, people with major in physics or in science, they also need trigonometry, and so on. So that basically takes us back to this objective here, which is appreciating how each math course, each one of these courses, is actually needed in different measures. If you click on any one of them, you will see how different measures are utilizing this course. The second objective here is that recognizing that graduates of certain degrees may work in many different fields, which is obvious. You'll discover that people having the same degree, but different people having the same degree, but they work different job, and not just different job, different field. Like, for example, if I come here to calculus and I go to physics, okay, and I open this, you'll see that a lot of different people that have degree in physics, they are working in different fields. This guy's working in a technology field. Okay, and then this one is working in business and finance. This one is working on education, and this one is working on earth and environment. Very different fields. And guess what? All of them are just having a degree in physics. So not because you have a degree in physics, you are really confined to work in a specific field. No, the door is open. And the same for math and the same for science. The door is open to work in so many different fields. So my advice, start with, study what you like, and then also try to find the job that you like, even if there are some differences between them and not exactly in the same path. Okay, so that was part of our objectives. We go back to our objectives. We are also trying to see the examples of how math is used in different jobs. This is actually the details that we'll be looking at in any one of these. So for example, if I look at, for example, arithmetic, in finance, how arithmetic is used in finance. You're just going to open one of these and just find out how he's actually using arithmetic in finance, like use basic mathematics, percentages, compounding, in calculating income tax, projection of the investment returns. So that's how actually math is used. This is what we will see in more detail in each one of these. Finally, is awareness of some of the most practical advices regarding mathematics in life. We'll see how those people who are actually using their math in their career, what will be their advice in general, to you if you want to pursue their career, or if you're still a student, or general advices that can help you, in life in general. So let us take our tour and try to, find more detail about all these objectives. Okay, so I'll go back now to the beginning. Here we have different courses. So let's start with arithmetic. What do you like? Is any specific preference? Do you like to start from anywhere? Which one is more interesting to you? So I'm looking at the chat now and see what people prefer. Logic. Interestingly, statistics, I guess. Okay, right. I'll do logic and statistics. Actually, logic here is very interesting because when I said logic here, I meant two things. It's a course in logic, that's one thing, and also the logical reasoning that mathematics instills in you. And every one of these is just a course, arithmetic course, algebra course, trigonometry course. But here in the logic is the only one that I talk about two things. The course that teaches logic, and also in general, how math affects your logical thinking. So let's open this and have an idea. Well, we have different career paths here. We have a degree in finance, in arts, in math, and in physics. So if you go to finance, for example, let us see what the examples we have here. Okay, we have someone who's working as a manager. Okay, and the field, of course, is business and finance. And the job is to manage relationship with service providers and monitor, trading parameters. Okay, so what is the use of math here? Okay, she used basic math, she used Boolean logic. That's what we talk about, the courses in logic, or the Boolean algebra, or the Boolean logic. She uses also statistics, which is used in financial analysis. And she has a very interesting quote here. She believes that math degree is a good basis for a wide range of jobs. A math degree is a good basis for a wide range of jobs. And she obviously have a degree in probably financial math or something like this. She has a degree in finance, but she has also probably a degree in mathematics. So by the way, speaking of this, I'd like to tell you that the information I have here in my presentation, they all came from, I don't know if you'll be able to see this. If you open another tab, hopefully you can see this, right? Okay, you all came from We Use Math website, which I probably presented in part in my previous presentation. But when I looked at the different, here they organize everything by field. And when I tried to extract the information from here, I just found it overwhelming, and I choose to organize it in a different way, which is instead of organizing it by field, I would organize it actually by course. So I also summarize many of the information, because if you open here, for example, this one is here. If you open this one, actually, you find maybe a lot of information that I had to summarize many of these information just for you to present the most important maybe points that you would be interested in. So that's basically my job. I just want to make sure that all this information is not, I'm not the one who collected, but it's been actually, I put them from this website. Right, so going back here, that's an example of using mathematics and Boolean logic in particular, which is the topic that we choose here, logic. Okay, so it's used in finance. What else it's used? It's actually used in arts. But arts, I have another one to show you about arts. We'll come back maybe to this. But interestingly here, in some of the galleries have been using Boolean logic as well. This guy is just, or this lady is an artist. And it's just, she just makes sculpture, installation, and animations in exhibitions, galleries, different public spaces. She's an artist. You might think, why would an artist need a mathematics? She interestingly, she have been using Boolean algebra in one of her exhibitions, and I'm actually showing a picture of this exhibition, but I guess in a different part. I think we'll come back to this. Or maybe if you want, I can just show it you. I think I'm showing it here in the arithmetic, because many of these, yes, here. Many of these are actually using, yeah, that one. I mean, she is saying that she used Boolean algebra to build, this piece of art here. Okay, so interestingly, you probably think something like this is maybe too far. But actually, no, it's been used to build something like this. And actually, these pieces, we cannot stick it together. She just put one on the top of the other. And the rule is it should not touch the ground. And, and it's not just, it's okay to touch each other and it's okay to touch the ladder, but not touching the ground. So interestingly, logic has been used even in arts, which is probably some of you did not really think this would happen. So logic is used in finance, used in arts, used in mathematics, of course, physics and mathematics. Probably it will make sense to you that, okay, logic is used in people with math major or in physics major. So let's look at the examples of how people use logic in math major. Interestingly here, if you remember, I said, we will be talking about two things: the use of logic as a course, like in Boolean logic, and we will talk about something else, which is the logical thinking that mathematics gives you. So this guy, even though he is, had a major in math, and he's working as a vice president of a company, which is, a big job, he thinks that the biggest benefit of math, I don't know if you can read this, should I make this bigger? The biggest benefit of math is the mental agility and way of thinking that helps in problem solving. So it is not really, even though he has a math major, but it is not the math itself, but it's just the effect of the math that he studied. The effect of the math he studied, he believed, it's just, this gives you the biggest benefit of math, which is the mental agility and the way of thinking it gives. Okay, moving to someone else. This lady is a data analyst. She also has a major in math. She has a degree in math. And her job is to pull key messages from data. And again, she thinks the benefit of math really is the logical viewpoint that studying math grants. It's not the particular course that you studied in math, but the effect of studying math in general. Now you start having a logical viewpoint, and that helps you in your, according to her say, in any data science rule, Let's see another example. Okay, here's another example of, again, a major math graduate who is working as a risk manager. And interestingly, she said, I did not specifically use any mathematical technique or methods that I learned in the university, even though she is a math major. However, the mathematical flair and the sophistication which I greatly enhanced in university are essential skills for problem solving in both in and out the office. So that's very interesting quotes here. Those people, even though they graduates in math, they didn't say algebra or calculus or trigonometry or that helped me that much. No. They are not thinking, they are actually thinking beyond this. They're thinking about the effect that happened to their brain and how it affect their performance in the job in general and in life as well. That's quite interesting here, some of these examples about math. Okay, so let us see in physics. Let's see some examples, how people use, what would they say? People who have degree in physics. We have an operations analyst here, and he's writing code, it's more like a programmer. And he uses algebra, calculus, physics. He's clearly mentioning the courses that he's been using, but he's using this for also coding, like in programming, use all these kind of mathematics. And again, but he's again stressing that the math help in understanding the logic behind problems. And you can use this and apply it in more difficult problems. So again, that's the biggest benefit of math for him. It's not in particular the algebra or the courses that he took to write software programs, but the logic that he learned in math that help him solve problems. So that's again some of the examples of how mathematically, the person becomes logically more, think more logically when you study mathematics, in addition, of course, to the use of logic itself. Right. If you paid some attention, maybe I can ask you some questions related to the presentation. Second. Let me give you some questions related to this part so far. The first question is, okay, complete the following sentence. Something helps in understanding the logic behind problems, which helps in solving more difficult problems. A, physics. B, English. C, chemistry. D, math. Which one shall I choose? Can you hear me? Did you see the question? From the presentation. Yes, very good. D, excellent. Yes, the answer is D. That was one of the quotes mentioned by one of the people that I just showed now. He said that math helps in understanding the logic, okay, the logic behind problems, which helps in solving more difficult problems. So now we're talking about the benefit of math in general. The second question I have for you is actually a logical circuit. It's actually a logical circuit, which is like a question from digital logic. And I don't know how much you know about this in school, or if you have any background, but I thought some of you might know about this. So I thought, let me test if you guys know about logic or not. Here's a logical circuit. This is a NAND gate. This is an XOR gate. Let me try to just focus here. And this is an XNOR gate. And suppose A is equal to 1 and B is equal to 0. What do you think the output will be? Are you familiar with this kind of circuits? Are you familiar with this kind of circuits? You didn't learn this in school yet. I think in computer programming, I think somewhere, I think my son is grade 11. I think he studied something like this in grade maybe 10. Or maybe it depends on the school, maybe. Yeah, depends on the school. Okay, Tanzil, okay, we have a number of people here. Yes, Tanzil said 1. Very good. Yes, it's actually 1 because, the NAND is 2 parts, and then negation. The AND has to have both of them 1, but both of them are not 1, so it's going to give you a 0. But the 0 is negated here, so the C will become the opposite of 0, which is 1. How about the D? The D has XOR. XOR measure the difference. They are different. So if they are different, it will give you 1. So C is 1 and also D is 1. What will happen when C and D is 1? That this will be an input to, again, this XOR function, which is followed by NOT or XNOR function. And when they are similar, XOR will give you 0, but XNOR will give you 1, which is Q. That's why the output is 1. Anyway, I just went through example of logic quickly for the people who don't know what is logic and what is some of its applications. And also it was interesting to know if some of you know about it or not. So that was an example from logic and how people in different careers are using logic. Now, the next one people said they're interested to know is about statistics. What do people use statistics? Surprisingly, the greatest number of fields that use math course is statistics. Is here in statistics. Statistics used in science, in physics, in engineering, in finance, in math, medical. It's everywhere. It's everywhere. So that's quite interesting, actually, with the one that you picked. And that's why maybe in the university, like in Abu Dhabi University, statistics is almost taken by all the majors. All the students have to take statistics because they always need it anywhere, regardless of what is your field. You need to be aware of some of the basics of statistics. So when you come here, maybe choose engineering. I think that you will not differ that, okay, engineering uses statistics. We have people who are engineers here, stock trading educator. He's working in the field of education. And his job is actually to adjust investment strategies based on market movement. How he's using mathematics. Let me just try to fix that. Okay, he's using mathematics. He's using statistics and probability in plotting and charting and calculating averages, percentages, and ratio, which is very basic stuff, that he's using statistics in. Okay, so that's one example from engineering. Let us see an example from, math, for example. I think I'm talking about people who have major in math. These are majors. When I said physics or math or engineering, these are different majors. People have a degree in math or degree in engineering. So we have Ken here, who is actually an applied mathematics professor. That makes sense. He's modeling human immune system. That's maybe his research interest. He's also teaching and training because he's a professor. And he's, of course, working in activities related to the running of the university. And he uses probability and statistics. It looks like this is his main field. But look at this interesting advice. Again, the biggest benefit of math is the structured way of thinking that it provides. It looks like all math measures are like that. Maybe they all agree to say that, or similar, something similar to that. The biggest benefit of math is a structured way of thinking that it provides. Mathematical training heavily influences how one understands, tackles, and solves problems. So we all agree on the importance of learning math and how this helps you in solving problems. I mean, he's saying problems here, he did not say math problems. He just said problems in general. Okay, so that's an example of a mathematician who is using statistics. How about the medical? Okay, what is this? A medical doctor? Let us see. A medical doctor is using statistics. Okay, that's interesting. Okay, how is she using statistics? This is a medical doctor, GB, general practitioner. She's a family doctor. She provides complete medical care to all people, all stages of their lives. And she uses basic conversions when calculating doses per weight, amounts in mixing for dilutions. And she also uses statistics to analyze research papers to stay up to date. I mean, maybe she's not using much math in her daily work, but she needs to be updated with research results. So she needs to be able to evaluate and analyze these research papers just to be up to date. So that itself requires some knowledge of statistics. She has interesting advice here. You don't need to be extremely smart to get the job you want. You just need hard work and dedication, because some people think, you're a medical doctor, because you're too smart. Actually, she's saying it's just hard work and dedication. So that was about some of the examples we have here also in the medical field using statistics. Okay, what else? We have physics and we have science. The biggest one actually is science. The biggest one is science because in science, a lot of people are using statistics. Some say that actually science is all about statistics. Here's an example of an epidemiologist. I'm sorry, I'm not able to pronounce this properly. Epidemiologist, maybe it's better. And she's working in the healthcare field, which is doing research initiatives to prevent, control waterborne diseases. Waterborne diseases are the diseases that comes or transmits due to water or in the water. So here, how she's using mathematics, and just maximize this better. Okay, she's using descriptive and inferential statistics to analyze the data and measure the frequency of illness and the spread and the speed of the spread of diseases, look at distributions and predict outbreak. So that's all this work is just a statistics based. All this work is a statistics based. So this is an example of using statistics in science. Another example. Here we have another person who looks like he's living in the water. So he's marine geologist, and his field is Earth and environment. His job is to create 3D maps of the seafloor, analyze and process the data, and do some mapping and reporting. How does he use math? He said he's reformatting the data so it can be processed, and also writing short pieces of code in Microsoft Excel. So he's using Excel, he's writing a little bit of smaller amount of programming. That's maybe why he's advising to learn Excel and basic programming. Okay, so here are some of the examples on using here also another example. All of these are in science. Okay, in Earth and environment, again, marine geologist. She's using mathematical models and satellite data to observe and analyze the oceans. So this one's working with satellite data and oceans. And she said, interestingly, I use every math course I learn it. Wow. Yeah, she is not a math major. She's physics, yeah, or maybe science. Yeah, she's science. She has a degree. I did not maybe write the degree, but it's somewhere in around science. So geology. And she said, I use every math course I learned to do the statistical analysis. And she said, I use math and physics every day. She used math and physics every day. So here's some of the interesting examples about use of statistics in science. Okay, and maybe there's one more. Yes, here, interestingly, we have a data analyst who has a degree in physics, and he said mathematics is used to formulate and describe problem when you want to solve the algorithm as well as writing the program. Right. Anyway, we have seen a lot of examples, and now it's time for questions. Questions related to the use of statistics as a course in different fields. Okay, it looks like I have only one question here. In order to get, there's an advice from one of medical doctor that was here in this presentation, and she said, in order to get the job done, in order to get the job you want, number A, you need to work hard and be dedicated. Or number B, you need to be extremely smart. Which one is right? Which one is right? What do you think? In order to get the job, number A, you need to work hard and be dedicated. Very good, very good, exactly. So that's I think that was an easy question here. I just put an easy question. Right. Let us move to a different field. Maybe I'll choose this time. I'll choose arithmetic, and see how arithmetic is used in nursing, engineering, finance, art, and math. So I'll pick some of these. I don't have to go through all of them so that you don't get bored, but I'm going to ask you questions. For example, here is an airline pilot. I mean, he's using arithmetic. Okay. How is he using arithmetic? He said his job is to conduct a flight in a safe manner to the destination and taking into account many factors. A lot of adding, subtracting, dividing, and multiplying, which is basic mathematics, yeah? Mostly related to the weight, weather, and fuel. Some simple trigonometry is also used. So here's an example of using mathematics in a very simple way. Like whenever it comes related to the weight, maybe the weight of the aircraft, with people or without people, with cargo, without cargo, weather, different conditions, fuel, and so on, maybe the prices of the fuel. So you're just using basic arithmetic use, not much really math. But interestingly, he is an engineer. He's an engineer. Okay, let us see. We talked about the art before. I showed you the picture. Let us see nursing. How math is used in nursing. Okay, observing, see, this is the job of the nurse, observing and reporting on patient's condition. How does she use arithmetic? She uses arithmetic and statistics in calculating the dose, the conversions, and recording also, and graphics. So here are some of the examples of using arithmetic. I think arithmetic is just, everybody knows what's arithmetic, and you probably won't disagree with me that arithmetic is needed in different fields. And I guess I can go ahead and ask you some questions about it. Okay, the questions that we have here, I have some questions, mathematical questions. I'm asking you arithmetic questions. Yes, yeah. So I just had to cut because I just found that probably we're running out of time and we won't be able to see everything. So I had to cut short on some of these. Let me just 1 second. So for example, here I have easy example, simple one. The order reads 600. This is related to nurse. Yeah, nurse job. The order reads 600 milligram. The tablet contains 200 milligram each. How many tablets should be given? I think that's an easy question. You can answer that quickly. Just lost the chat window. Okay, yeah, that was an easy one. Yeah, very good. Now let's move to something else. So maybe you think the job of the nurse is very easy. She doesn't use much math. Okay, here's another job. Doctor orders 12 milligram per kilogram of one medicine, okay? This is milligram of medicine, and this is the kilogram, okay? One second. And they want a number of things. The first thing we want is that how many kilograms. First of all, it's supplied in a specific way, which is 100 milligram per 2 milliliter. That's the way it's supplied. And also the patient weight is 115 pounds. So approximately how many kilograms is the weight of the patient? And I try to divide the question into smaller parts so that it becomes easier for you. And so first step, how many kilograms is the weight of the patient? You know, knowing the conversions here is one of the jobs that the nurse has to be able to do. So for example, you know, you should be able that every kilogram is almost 2.2 pounds, and this is 115 pounds. So all that you have to do here is what? To convert the weight of the person from 115 pounds to the number of kilograms. What shall I do? How many kilograms is this person? Yes, exactly. So if I said how many kilograms, usually I mean something countable. Something countable, and I will ignore the fraction. I will only use 52. Very good. The second part is how many milligram of this medicine does the patient need? How many does he actually need? The doctor prescribes 12 milligram per kilogram of, what does it mean? 12 milligram of medicine per kilogram of the weight of the patient. That's what it means, 12 milligram of medicine for each kilogram of the weight of the patient. So in this case, how many milligrams now of this medicine does the patient actually need? What shall I do? .2, yani you divide it. Did you divide? You know, is it 12? And if the person has weight 1 kilogram, he should take 12 milligram. If the person weight is 1 kilogram only, I mean, I don't think there's a human being that has a weight 1 kilogram, but if the person has weight is 1 kilogram, he should take 12 milligram. What if he has more kilograms? What if he is 10 or 20 or 50? You think he will take less amount of milligrams or more amounts of milligrams? I mean, if the bigger the weight of the person, I think you should take more, right? So that means you should, yeah, you should multiply. Exactly, you should multiply. So part of this is also, you know, if you memorize the rules in schools, you'll forget them. Yeah, but if you think about it logically for a minute, you know, if 1 kilogram should take 12 milligram, what if I have 50 kilogram? I should take more, so I have to multiply by 50. So yes, the answer is actually going to be, 624. 624, as you said. Right, very good. What else? How many milliliter per dose will you administer? Imagine now you have this 624 milligram required for the patient. How many milliliter? Because the medicine comes, you know, as supplied like this. You know, every 2 milliliter will have 100. It comes as liquid. The medicine comes as liquid. So we need to know how many milliliters are required. So very good. Tanzil said a very good answer, very close answer, which is 12. And the right answer is actually 12.5 milliliter, which is almost like, you know, maybe a teaspoon and a quarter, usually. Sometimes we think of it this way, yeah. 10 milliliters like a teaspoon, and this is like a teaspoon and a quarter. So that's the amount of medicine that the patient should get. Anyway, so it's all of these calculations. Sometimes, you know, if a medicine is if a patient is in the hospital, and a doctor just give the number, then the nurse has to make all these calculations to know how much exactly she should give to the patient. If she makes a mistake here, I mean, this is not good. I mean, she really needs to know how to make these calculations. But another question here we have is, there was an advice. It looks like I did not show you the advice, maybe because I skipped some of the items. But I want you to guess, maybe, because I skipped some of the people and I skipped some of their advices. I want you to guess maybe here. One of the advices from the people using arithmetic, they said A or B or C. What do you think? Yes, Hassan, very good. Makes sense. Yeah. See, that's actually the point here. And it's some people are really struggling and they try to say, they cover it, which is not really good. I'm not talking about study only, study or work or anywhere. I mean, if you feel you're struggling, uh, you need help, then ask for help. Yeah, it's good to ask for help when you need help, and it's good to acknowledge, identify, know, and be aware that you sometimes are struggling. Yeah, I think this was an advice given maybe math. We didn't open math, right? Yeah, air traffic controller. Exactly. Yeah. So I think he said here, in your study or job, you need to be able to identify when you are struggling, ask for help. This guy is doing a very, critical job. He is safely guiding aircraft. He's an air traffic controller. He's sitting in the airport and is guiding aircraft how to avoid collapse. How to what is the best path. So, and he's using mental math. I mean, he has to calculate the rates of climb. This is an interesting thing. We shouldn't miss that one. He's using mental math and calculating rates of climb or rates of descent. Okay. So, for example, he need to quickly, in few seconds, only mentally, there's no time to grab a calculator, identify how many minutes I have to get the descending aircraft down. And I have to calculate quickly how many feet per minute I need to instruct the descending aircraft to do so, right? So this is a lot of, very critical job. It needs a person who is mentally really, maybe there's some kind of stress here. And that's why his advice is really very good, because if you feel you're stressed and you need some help in the job, you're struggling, you're tired, for example, and you have to say it. I mean, you have to seek help. You have to get help of someone. Maybe someone else can do the job for you until you relax or something. So this is a very precious advice. You should identify when you're struggling and really ask for help. I like this advice. Okay, so that was some of the examples of people who are using arithmetic, even if he has a math major, but he's using arithmetic, which is maybe the smallest, simplest branch of math, simply because he's using it mentally and he has to do it quickly. Yeah, that's the nature of his job. Right, we have seen a number of courses. So let us see what else. What do you prefer that we can look at next? Open my window, chat window one more time. Which course you feel you're curious to know why people are studying this course and who should study this course and what is the benefit of this course? So we talked about arithmetic, we talked about logic, we talked about statistics. We still did not talk about algebra or trigonometry. Okay, let's talk about algebra. Okay, of course, we are only talking about the sample here. I'm not saying that only math and science and physics measures are using algebra. I'm not saying this. I'm saying the sample that I have in this website have people who have major in math or in physics or in science, and all of them are actually using algebra. So for example, how a mathematician is using algebra, he doesn't have to be a mathematician. Maybe he studied mathematics, but he's not actually a mathematician. So this guy actually is a software engineer. He studied mathematics, but he's working as a software engineer. And he's developing and building software. And he said algebra is used every single day. That's interesting. He's a programmer, and he's using algebra every single day. I think understanding geometry is very useful for graphics. Working out how long a task will take requires some mental arithmetic. Again, that's another example of mental arithmetic. From time to time, you have to develop an algorithm to solve something. So it's crucial to understand also Boolean logic. So that guy is also using Boolean logic. So that's an interesting example of people who have major in math, but they're actually working in technology. And they are using algebra every single day. Right, let us see what else. In physics, who else is using algebra? Okay, we have an author here. And this author is communicating math and science in interesting, informative ways, which means he's writing books about math and science. And of course, he's using algebra, calculus, probability, because mainly his job is to educate people about the importance of these topics. So that's understandable. Okay, and then we have other examples, but this will be mentioned later in different fields. If you notice here, everyone or many of these actually are benefit from many courses, and I try to avoid redundancy here by mentioning each one only one time. Okay, another example here, hydrologist. Her task is to do hydrological or groundwater assessment for building and roads. Before they build something or create roads, you need to know the water level, and because the building will be affected by that. So that's her job. She needs to understand also how the equations work to manipulate them. She's manipulating equations, and that's why that's part of algebra, and is solving for the parameters required. And we have seen, you probably studied algebra, and you know it's full of equations and solving these equations. Very good. So these are some of the examples of how people are actually using algebra. A question for you. Okay, again, there is an advice. You still remember this. One of the advices from the people using algebra said that if you are struggling with a topic, did we miss that? I think we missed that. Did we miss that? Again, it looks like we missed it. I'll go back to it. But can you figure it out? Can you guess? If you are struggling with a topic, what shall you do? Ask very few questions, or ask many questions, or don't ask at all? I think it's obvious. You should ask many questions. And that's what a lot of students fail to do. A lot of students, they're struggling with something, but they just, khalas, it's hard. So they don't even ask. Actually, asking alone could be enough for you to move from, say 50% to 90%. Okay, it makes the whole difference. So asking many questions is, of course, the key. And that was one of the advices. I think maybe we overlooked it because we were going through them quickly. Right. Which of the following is true about algebra? We have seen a lot of things now about algebra. Only mathematicians use it. Only teachers use it. Algebra is used in many jobs, and some even use it every day. Yes, we have seen examples of people who are using algebra every single day. I think there was a programmer who was using algebra every single day. Yeah, software engineer. Oh, I have a mistake here. Sorry, it's a mistake in my presentation. No, it's actually C. Yes, you're right. Because C, algebra is used in many jobs, and some even use it every day. It's sorry, that's my mistake. Let us see an example: applications of algebra to physics. Okay, let us see if you are good in algebra. I'm going to ask you a good question about algebra here. A motorboat heads upstream a distance of 4 kilometers on a river whose current is running at 3 kilometers per hour. The trip up and back takes 1 hour. Assume the boat maintained a constant speed relative to the water. What was its speed? So that's again an application related to using algebra in physics. We have seen some of the jobs here, some of the people have here degrees in physics. So that's a simple example related to physics. I don't know if you can answer this, or is it hard for you? Actually, I think it's, the point here is not really to I want to see your abilities here, but I just wanted to show you, because when we study algebra, some students say, okay, why do we need rational equations? Who's using rational equations? What is the benefit of rational equations? So I'm just going to show you the answer here. I'm showing you how rational equations is used to solve a real life problem, a practical problem. So here the rational equation represents the total time the boat needs to go up and down the stream, and going in one direction and coming back. Going in one direction against the stream of the river, like against the direction of the water, and then coming back with the direction of the water stream. So when you go against it, of course, he will be slow, the boat, and when you go with it, he will be fast. So there are two different speeds here. One will be, if you consider the speed of the boat is s, and we have the speed of the stream here is 3 kilometers per hour. So one time is going to be s minus 3, one time will be s plus 3. Like, why this is fraction, why this is fraction? Because we're using the time, the total time. The distance is 4 kilometers. One time you travel this distance with this speed, and the other time you travel the same distance with this speed. So to get the time, you divide the distance by divide the distance by the speed in order to get the time. And he said it takes 1 hour. So the total time is 1 hour. The total time is 1 hour. So I had to build this equation to know the speed of the boat. I had to build this, and this is a rational equation. So I have to have skills to be able to solve a rational equations where the variable is actually down in the denominator, right? So anyway, I'm hiding the detail here. If you're good in solving rational equations, if you like rational equations, then probably you know that the speed now is 9 kilometers per hour. If not, then at least when we come to rational equations in the university, when you study these, regardless of what is your major, you will know that it's something really has applications. One of the difficulties the students have is that maybe they don't see practical applications to the equation that they learn. And this could be due to the course's size is large, and many students are reluctant. They don't want to see like these word problems in exams. They say it's difficult. But as a result, when you don't see it, you don't feel it's practical. You feel the course is useless. And as a matter of fact, the course is not useless, but maybe because we are focusing so much in education in the theoretical part, maybe because it's easier, or maybe because the course is large and there's a lot of content, we end up losing, you know, the fun part of it. You don't really know how this equation is used and what is the benefit of this. Okay, when do you discover the benefit and the usage? When you go to the job and you start using one of these, then you start appreciating, you know, that background that you have in algebra or in different fields. Okay, so that was some of the examples about you know, different courses and how they're used in different jobs. I initially requested 45 minutes only. I don't know if I still have time to go more, or shall we just conclude with the results of these courses? You probably get the idea. You probably guessed that when you go to trigonometry, you find it used by so many different fields, including some of them you did not expect, like arts, for example. You probably guessed that when we go to geometry, for example, also used by so many different you know, measures. Geometry is used including art, including engineering, including science, physics. All of those people that graduated with a degree in physics, science, engineering, they are all using geometry. Same thing for calculus. Maybe calculus has less degrees that will be benefiting from calculus, but they do exist. But they're actually including the science also. People who are in science, they use calculus. So all of these are maybe some of the examples that can tell you that every single course, you know, has a lot of possible applications and is used in so many different measures, and in the job also is used in so many different ways. So that will probably give you, you know, an overview on you know, what did I want to say today and what those people are trying to say today. I'm going to, I keep losing the chat and open it again. Why is physics separate from the sciences in this illustration? Well, I just found that because physics is, it's a good point. It's a good question. I found a lot of people who have specifically a degree in physics. They use a lot of math. You know, physics is one of the closest sciences to math. So that's why I separated it. You know, maybe it's not originally separated, but I separated it because it has so many. I had so many people who work who has a degree in physics, and they ended up you know, using mathematics a lot. And the closest field, even until my son, you know, I like to teach math and I like to teach physics. So if you have a question in math or physics, come ask me. Usually people who like math, they like physics. Usually who like physics, they use math a lot. So they're kind of connection between them. So I kind of separated it from the science. So thank you for the question. It's a good question. Nabil is saying the math is basic of everything in our life. Actually, there's an interesting comment here, but we didn't probably see it. I don't remember really where was it, but someone was saying that math is the glue that attach so many different disciplines together. I like that statement. It is the glue that connects so many scientists together. So because we are running out of time, I'm going to just jump to the conclusion. I think we have covered many of the objectives of today. So we talked about, even though I did not finish my presentation, but my time finished. We have seen how each math course is needed in many different measures, and we have seen that even graduates of certain degrees work in many different fields. Like, for example, a mathematician is working as an educator, or working as a software engineer, or working as a pilot. Sorry, not a pilot, it was air traffic controller. I mean, so many different jobs. Like, some of them were saying that, you know, a math is like a foundation of so many different, sorry, it opens the door for many different careers. You can, if you have a math degree, you can work anywhere. Anyone will welcome you if you have a math degree. So we have seen some of these. Let's come to the conclusion. I know that we have not explored all the possible examples, but you have seen some of them. Many of those interesting now. If you went through all of the examples you have seen, many of the people with non-math degree, they use math in their job, and some even use it on a daily basis. I remember there was someone who studied physics, I think, or science. Sorry, science. It was maybe marine something. You know, she said I use math on a daily basis, every single day, even though she's not a math major. That was one side. The other side is that on the other side, many of those who have a degree in math believe that the most important benefit of math is not that it has wide applications. It's not that it's used in every job. No, they think the benefit is something else. The benefit is the mental agility and the way of thinking. It is the logical viewpoint that it grants. It is a mathematical flair and sophistication. And all these things help in solving problems in both inside the office and in the real life. And by this, I conclude my presentation. I'd like to thank you all, the audience, and if you have any questions, feel free to share with me on the chat. Thank you so much. Okay, great. Any questions? Thank you so much. Thank you so much. So that was, I'm glad to have you today, and I hope you really benefited something from today's presentation. Assalamu alaikum wa rahmatullahi wa barakatuh.